Evolution of Mechanical Ventilation, a documentary by Camille Stover. The evolution of mechanical ventilation is a fascinating tale to be told, with the stories of artificial ventilation trailing back through the tales of time. The use of artificial ventilation is written in the Bible, described by the Chinese in 2000 BC, and was studied by physicians such as Galen, Paracelsus, and Hippocrates. In the 1500s, Andreas Vesalius describes using bellows attached to a tube in the trachea to inflate animal lungs. Negative pressure ventilation was used throughout the 19th and 20th century as the main form of ventilatory assistance. The use of the tank ventilator was first described by John Diehl in 1838 and was modified and adapted over the next 150 plus years. Negative pressure devices were airtight boxes that surrounded the patient's body except for their head. Negative pressure ventilation really became popular during the polio epidemic that occurred from the 1930s to the 1960s. Patients suffering from poliomyelitis with worsening respiratory failure were placed into the iron lung to provide ventilatory support until the time when they could support their own ventilatory demands. The use of negative pressure ventilation was the first form of consistent artificial ventilation. However, it lost popularity around the 1960s due to the creation of smaller and more portable intermittent positive pressure devices, known as IPPV, and ICU volume ventilators. The use of positive pressure ventilation began in the 1950s. These first-generation ventilators had no way to provide PEEP, were only volume controlled, and did not allow patients to trigger ventilator breaths. They also lacked the ability to monitor values or alarm. In 1954, the Merck respirator contained a single limb circuit, was driven by a piston, and was designed to fit under the patient's bed. There were no specific settings to ventilate the patient at, and gas was delivered at a set IDE of 1 to 2. A few years later, the Emerson 3PV came into circulation. It had the ability to monitor some pressures and volumes and an adjustable I to E. Other first-generation ventilators include the Draeger Spiramat and the Ingstrom respirator. The second generation of ventilators started with the Puritan Bennett MA1. This generation of ventilators offered PEEP, but was still only volume controlled. They had some patient monitors, such as tidal volume, respiratory rate, and pressures, and were able to alarm high pressure, high respiratory rate, and low tidal volume. Late second generation ventilators added a demand valve that allowed patients to trigger breaths. They also had the ability to do IMV with the use of an external gas source. The Servo 900C, a late generation ventilator, allowed the use of pressure support and pressure control ventilation. The third generation of ventilators had a microprocessor control, the ability to flow trigger, had IMV, pressure support, as well as the ability to do pressure and volume control. SIMV could be done in volume and pressure control, with pressure support added to the IMV breaths. Some third generation ventilators had airway pressure release ventilation, or APRV, available. Third generation ventilators had the ability to monitor volumes, pressures, rates, and the function of the ventilator. They could display pressure versus time, flow versus time, and volume versus time waveforms, as well as pressure, volume, and flow volume loops. They had extensive alarms incorporated into the ventilator. These ventilators were revolutionary for their time. The fourth and current generation of ventilators are by far the most sophisticated and advanced ventilators on the market. They have extensive monitors and alarms like no other ventilator has had. They offer a variety of new modes of ventilation, and they are able to provide invasive and non-invasive ventilation with the same machine. They can monitor and calculate countless values. Some have the ability to record the electrical activity of the diaphragm. Others measure the change in pressure in the esophagus. They have specialized inspiratory and expiratory valves that are able to deliver the smallest volumes. These ventilators are able to support patients of all sizes and disease states, all the way down to a 500-gram neonate. Mechanical ventilation in medicine has evolved by leaps and bounds over the last century, with no sign in stopping. Here's to the next 100 years of mechanical ventilation.